So now we're going to talk about our required practical, and it's to make up a volumetric solution and carry out a simple acid-base titration. So what we're going to do is to prepare a solution of sodium hydrogen sulfate that has a known concentration, and then determine the concentration of sodium hydroxide by titration using this solution. So the method is in two parts. The first part is preparing a standard solution, and then the second part will be actually conducting the titration. So for part one, the first thing we do is weigh out exactly 2.7 to 3.3 grams of the sodium hydrogen sulfate solid. And we put that directly into a beaker and record the actual mass that we've weighed out. And then we make this up to a 250 centimeters cubed solution for use in a titration. And we do this using a wash bottle like in the diagram. And we also make up this 250 centimeters cubed solution in what we call a volumetric flask. So this is the type of flask that we see in this diagram. So this is our volumetric flask. So whenever we make standard solutions, we always use this kind of flask, and we fill up to the calibration mark with the water from the wash bottle. And then for the third step, what we do is calculate the exact concentration of the solution in decimeters cubed. And then moving on to part two, which is determining the concentration of sodium hydroxide by titration. The first thing we do is set up the buret and fill it with sodium hydrogen sulfate. So when you're filling it up, make sure you don't have any air bubbles and it's filled up all the way to the bottom. And so you should have something that looks a bit like the diagram on the right. So we have the stand and then the buret in the buret holder. We then transfer 25 centimeters cubed of sodium hydroxide into a conical flask. And we'll do this using a pipette probably. And then we add 2 or 3 drops of phenolphthalein indicator into this conical flask and note the colour of it. We then carry out the titration until the indicator changes colour permanently, and record the volume of sodium hydrogen sulfate that we actually added to this conical flask, and then note the new colour. So how we carry out the titration is we keep on adding this sodium hydrogen sulfate by opening the tap on the buret. And we do that with one hand, and then with the other hand we swirl the conical flask. And so after a while, so after some amount of the sodium hydrogen sulfate has been added, the indicator should start to change colour. And when it changes colour permanently, we then stop adding the sodium hydrogen sulfate and then record how much we've added. We then repeat this titration until we obtain 3 concordant results. And what that means is that they all have to be within 0.1 centimeters cubed of each other. And then we record all of the results that we've obtained, so every single volume, so all 3 of the concordant results. And then we construct an equation. So this will be the chemical equation that we're reacting, and we use this and the mean volume of the sodium hydrogen sulfate. So we use only the 3 concordant results for the mean and not all of the anomalous results, and use both of these to calculate the concentration of the unknown sodium hydroxide. So what we need to work out the concentration of the standard solution of sodium hydrogen sulfate we have, because we didn't measure out an exact mass. So say, for example, we had 3.29 grams of sodium hydrogen sulfate. So the mass of sodium hydrogen sulfate is equal to 3.29 grams. So that's what we got from the scales, the balance. Then we could work out the moles we have, because moles of sodium hydrogen sulfate is equal to mass divided by molar mass. So we could do 3.29 divided by the AR of sodium, which is 23.0, and then we add the AR of hydrogen, which is 1.0, and then we have a sulfur, which is 32.1, and then we have 4 oxygens. So that's 4 times 16. And this gives us 0.0274 moles. And so now we can work out the concentration of our standard solution, because we have the formula moles is equal to concentration times by volume. So if we rearrange this, then we get concentration is equal to moles over volume. And so we can use this to find our concentration. So we have that the concentration of this sodium hydrogen sulfate, our standard solution, is equal to 0.0274 divided by the volume, which is our 250 centimeters cubed, because that's what we made it up to. And remember that this volume has to be in decimeters cubed, because concentration is measured in moles per decimeters cubed. So we would have to convert it. So we would have 250 times 10 to the minus 3. So we have to divide it by 1,000. And so we get 0.110 moles per decimeters cubed. And now we can use this for our titration. So for part 2, for our titration, the colour change should be pink to colourless. So we have that phenolphthalein changes from pink to colourless. So that means that in an alkaline condition, it's pink, and then when it gets neutralized, it becomes colourless. And say we had that the mean volume of this sodium hydrogen sulfate that we had in the buret added was equal to 22.30 centimeters cubed. Now we can work out our concentration of the sodium hydroxide. So firstly, what we do is we work out the equation. So we have sodium hydroxide, and we're reacting this with sodium hydrogen sulfate. And this is going to form a salt and a water, because this is a neutralization reaction. So the salt would be sodium sulfate, so we'd have Na2SO4, which you probably put in state symbols as well. So we have, this is aqueous, and this is also aqueous. And then this will be our salt, so it's a solid. And then we'll have water, which is a liquid. And now we have to balance this equation. So we have a look at the sodium and then the hydrogen, and everything actually looks balanced. So this is our equation. And now the next step is to work out the moles of sodium hydrogen sulfate that we've added. So we've got the moles of sodium hydrogen sulfate added will be equal to the concentration of this sodium hydrogen sulfate solution multiplied by the volume. So we've got the concentration we worked out to be 0.110, and then we multiply it by the volume, and the volume we added was this 22.30 centimeters cubed. So again, we need to convert it to decimeters cubed. So we've got 22.30 times 10 to the minus 3, and this gives us 2.453 times 10 to the minus 3 moles. And so now we can use our equation to work out how much of this sodium hydroxide we must have had, because we can look at the ratios. So from equation, we have that 1 mole of sodium hydroxide will react with 1 mole of sodium hydrogen sulfate. And so therefore, if we have 2.453 times 10 to the minus 3 moles of sodium hydrogen sulfate, then that means we must have 2.453 times 10 to the minus 3 moles of this sodium hydroxide because they're in a 1-to-1 ratio. And so what we can do is now work out the concentration of this sodium hydroxide because we've got the moles now and also the volume it's in. So the concentration of sodium hydroxide is equal to the number of moles, so 2.453 times 10 to the minus 3, and then the volume. So we added 25 centimeters cubed into that conical flask. So that's the volume we use. And so we have to convert that. So we have 25 times 10 to the minus 3, and this gives us 0.0981 moles per decimeters cubed. So now we've found our concentration of sodium hydroxide.